Okay, so I'm going to work through an enantiomeric excess problem. I'm going to do this with one of the 20 proteinaceous amino acids, meaning it makes up the proteins that make up you. So alanine is an amino group with a carbon, saturated carbon with a carboxylic acid, amino acid. You may wonder about the charge. We'll talk about acid-base chemistry in a couple of weeks, but an amine is a strong enough base to deprotonate a carboxylic acid, and so in solution at neutral pH, this is the form this molecule adopts. So that's alanine. The specific rotation, which I talked about in a previous video, if you haven't watched my rather long enantiomeric excess tutorial, go do that now. The specific rotation for L-alanine is minus 15 degrees. So L-alanine is the minus enantiomer of alanine. Okay, before we get into enantiomeric excess, hit pause and name the enantiomer of L-alanine. All right, are you back? So the enantiomer is D-alanine. That's unnatural. You have no D-alanine in you. You've got a bunch of L-alanine in you. You're very good at making just L-alanine. All right, it's also, probably don't need a comma there, plus alanine. So in these are not absolute. So L and D do refer a little bit to plus and minus. It's kind of a longer story on how L and D came about. It's worth a read. It's pretty interesting. I'm not going to talk about it a lot in class, but it's an interesting story. So L and D don't tell you minus and plus, but L is the enantiomer of D, D is the enantiomer of L. Plus tells you the direction of rotation of plane polarized light of the molecule, as does minus. The enantiomer of the minus enantiomer, the minus compound, is the plus compound. The plus is the enantiomer of the minus is enantiomer of the plus, D is enantiomer of L. So all you got to do is, if I ask you to draw the enantiomer of a molecule with a plus in front of it, if it's got R's and S's, switch the R's and S's, switch the pluses and minuses, switch the L and D. Okay. Oh, yeah, so. So I'm going to say that you have a mixture that has an observed rotation of plane polarized light of plus 12 degrees. So what is the mixture composed of? And what is the percent EE? The enantiomeric excess. So you should probably go ahead and write these questions down. I'm going to ask you to hit pause, and then I'm going to erase these because I have a limited amount of board to work on. And you should probably also solve these in the reverse order. Solve EE first. That's my hint. Okay? Hit pause, go away and do that. So percent EE is, by definition, the observed rotation divided by the specific rotation. In this case, plus 12 divided by 15. I put that plus in there. You don't need it. The plus is going to tell you which enantiomer is the major enantiomer. So this is, golly, what is that? That's 4/5. So this is 80% EE with D plus alanine as major component. Right? There's more D-alanine than L-alanine, and you know that because the direction of rotation of plane polarized light is plus. L-alanine rotates plane polarized light counterclockwise, or in the minus direction. We're observing a clockwise rotation. Therefore, you know that there's more D-alanine than L-alanine. 80% EE. Very good. You answered the second question. What about what's the composition? How much D and how much L do we have? All right, again, percent EE also equals percent D minus percent L. In this case, again, D is the major enantiomer because the direction of plane polarization, the rotation of the plane polarized light. So we have 0.8 equals %d minus %l. And it looks like we're screwed, doesn't it? Two variables, two unknowns, one equation, can't solve that. Remember algebra. Once upon a time you took algebra. The %d plus a %l equals 1, right? They compose the entire mixture. So whatever d is, whatever l is, that's the whole thing. So %d equals 1 minus %l. All right, I'm going to go back up top here. I'm going to erase right here. Again, just rewind if you need to. So now we have 0.8 equals %d minus 1 minus %. Oops, sorry. Guess don't rewind. Fast forward through that bit. Should have said that. So 0.8 equals %d minus %l. %d is 1 minus %l minus %l. So 0.8 equals 1 minus %l minus %l. And so you can rearrange this to 0.8 equals 1. So this is now going to be minus l minus l. This is minus 2 times the %l. So 0.2 equals 2 times %l. 1 minus l. Have I done this right? Yeah, it looks like it. I'm going to get a negative number though. That's not good. Oh, this is minus 2. Sorry. Plus signs, minus signs. Told you this wouldn't be a very math intensive course. If I subtract 1 from both sides, this becomes minus 0.2. Okay, minus 0.2 equals 2 times %l, and that gives us that the %l is 10%. So 10% of the mixture is L-alanine, or the minus enantiomer, and that means 90% is D, or the plus. Okay, so if you go through this, you rewind and work through it again. You want to take the observed rotation and the specific rotation to get enantiomeric excess. And then you use the fact that the two components are the only things in the mixture to solve the one equation, and that will tell you how much of each is present. So 90% is D, 10% is L. That's an 80% EE. It checks out. 90 minus 10 is 80. We said from the alpha observed divided by the specific rotation that it was 80% EE. So it all works out.